Thank you, Stefan. Evolutionary architecture is really about the concept of how do you set up an architecture, how do you plan when the very landscape is under constant change? When I started in this business longer ago than I care to admit, you could do long-term architectural planning because the technology landscape didn't change that quickly. But now it does. Fundamentally different approaches to how we want to think about systems are being introduced rapidly, and organizations have to respond to that. And so this notion of evolutionary architecture is, how do we start to think about doing architecture, which is important under this notion of constant change? So when you're involved in writing a book and coining a term, there are two things you have to do. You have to pick a name and you have to define it. And I wanted to tell you a little bit about why we chose the name evolutionary as opposed to some others. When I first heard Neil Ford talk about his ideas around this topic, he was calling it emergent architecture. And I had a conversation with him about why that was a really bad name. It was a robust discussion, because there's something about the term emergent that makes it seem ad hoc, and I'm just going to respond to whatever's there. And yet, while that works for emergent design, because there is one, we can pretty much agree, whether it's a financial application, a retail application, healthcare, we kind of know what good code and bad code look like. There is no such thing as one good architecture. The architecture that you need for a highly resilient trading system. When I say trading system, everybody thinks low latency, high throughput, got to respond quickly. Early in my career, I worked on a trading system. And in their wildest dreams, they never thought they'd do more than 100 transactions a day. What constitutes good in an architecture like that is very, very different than most other trading systems. And we have to be able to take that into account. I'll come back to that idea in a minute, but I do want to focus on one term that we rejected quite quickly, which is an adaptable architecture. And at least in English, when people hear the word adaptable, they think of an adapter. I have this thing, and it's going to allow me to plug things in, or I've got a knob that I can turn, or I've got a slot that I can put things in. And all of those things mean that you're able to predict what the change is going to look like. We can't predict the way our technology landscape is going to continue to change and evolve. And so trying to build those adapters is just writing more code, which is going to give us more bugs and make it harder to understand. And we're probably going to get it wrong. And so it's going to be even harder to make the changes we have to make. Okay, so with that context, I'm going to quickly go through the definitions because I wanted to spend a little more time talking about some of the background information. But here's the definition. An evolutionary architecture supports guided incremental change across multiple dimensions. And each one of these things is important. This notion of guided is where we capture, for my particular application, in my particular domain, in my particular organization, what constitutes good. And in this, we're borrowing an idea from evolutionary computation. When you think of something like a genetic algorithm, you have a fitness function, which tells you how close to the desired result you are. Well, we are borrowing that notion for architectures. So an architectural fitness function is something that's going to capture how close is my architecture to what I want to achieve. How am I doing? Is my architecture shifting and drifting away from those desirable characteristics over time? Or am I still achieving what it is that I want to achieve? And the single most important thing about a fitness function is that you and I will never disagree on whether or not the fitness function is met. So Maintainable is a really bad fitness function because you and I can argue about what might mean, what I might mean by maintainable. But cyclomatic complexity no greater than 30, or respecting the layering, or particular information about coupling, all of those things will agree on what that is. Now, fitness functions are certainly not new, even in technology. But one of the things that we've found as we've been talking more about these ideas is giving it a unifying name allows us to talk about issues of security and issues of observability and issues of performance and resilience using a unifying name. And it then allows us to do a bit better job of these trade-offs that we as architects have to deal with all of the time. Incremental change. There are really two different aspects to incremental change. How do you change the application? How do you change what it is that the system is doing? What is the mechanism for that? And then operationally, how do I deploy it? And one of the things I want to focus on here, when I first started talking about evolutionary architecture, people would come up to me at the stage afterwards, and they'd lean forward and they'd kind of whisper, "Don't you think you're being professionally irresponsible to talk about evolving an architecture? The architecture is the rock, the foundation. You can't change that." It would be irresponsible if we hadn't done all of the work in developing the ideas around DevOps and continuous delivery to make the processes of deployment so much more robust. Because yes, when you are changing out fundamental parts of your system, that's risky. You want to know exactly how that deployment is going to happen. You're going to want those disciplines of continuous delivery that allow you to be confident in your deployment process so that you can focus on where might errors be coming from the changes that I've made as opposed to the particular snowflakey state of my infrastructure at the moment. So continuous delivery, and I'll come back to this, is a crucial part. And then finally, across multiple dimensions. We're all architects. We love our ilities. This is a snapshot of ilities from Wikipedia. And when you look at these, one of the things that you should recognize immediately is you can't ever maximize all of these. Many of them are in fact incompatible. The more I increase my level of encryption, I will have to decrease my performance. Those cycles have to come from somewhere. If I encrypt less, I could obviously use those cycles for something else. So we have to choose for our particular system, which one of these ilities matters and how they matter and what level do we need. And what we're trying to say with evolutionary architecture is we're introducing a new ility of evolvability. And one thing to keep in mind is evolvability is just like all of these other ones. You might decide for your particular situation, it's easier to just throw the thing away and start over than it is to make something evolvable or maintainable. Evolvability might not be important to you. Now, if you're in a major enterprise and you've got all of these different systems and that architectural foundation is tying together an entire enterprise, you probably are going to want to worry about evolvability. But it may not be something that you worry about early on in a startup. So that's the whirlwind introduction to evolutionary architecture. But I want to talk about where some of these ideas came from and how we really evolved into evolutionary architecture. So in the beginning, there was the Agile Manifesto. And that manifesto had many principles underlying it. Things about rapid feedback, empowering teams, safety nets. And as we look at how our use of patterns and our understanding of agile software development evolved, we went through kind of these phases. We started, particularly in the XP world, with code and emergent design and the principles around continuous integration. Very early on, we had Martin Fowler's book, bringing patterns thinking to application architecture, enterprise application patterns. We had Gregor and Bobby's book on enterprise integration patterns. What are the architectural patterns that underlie the different ways we have different components within our systems integrating with each other, communicating and coordinating their activities? To me, one of the most important and least appreciated entry into this is the book Refactoring Databases. Having been around the Agile movement for quite some time, I watched how Agile, well, of course, it's okay for developers, but I'm a business analyst. I need, to be able to lay out my entire user journey. I'm a designer. I must be able to have everything pixel perfect. The one role that I thought really had a legitimate complaint were the DBAs, because data migration is hard. And as soon as you have something in production, you have to do migration. And this book, Refactoring Databases, brings thinking about refactoring and patterns to data migration, much like using continuous integration helps us pinpoint errors. That's what you get from this book. We've got an entire chapter that within the Evolutionary Architecture book that is really just a symbolic link over to the Refactoring Databases book. And I put continuous delivery, and it might look strange on a slide that's talking about patterns. But when you think about it, one of the things that we are trying to do in continuous delivery is understand what are the infrastructure patterns that are important, rather than having all of these different snowflakes in our architecture. Are there patterns that we can apply from a configuration perspective to our infrastructure? But continuous delivery, as I said before, also provides the foundation for us to be able to make many of these other kinds of changes, because we don't have to worry about deployment. We're de-risking deployment. So in a very real way, evolutionary architecture is bringing many of the same principles that we see in other aspects of agile software development into architecture. What can we do to maximize our feedback loops? The fitness functions are a big part of that from an architectural perspective. What can we do to empower teams? I'll talk more about governance in a little while. But I want you to think about all of those principles that underlie agile software development and think about what role they can play in architecture. And just like doing software development in an agile way didn't take away from the fact that we were developing software, bringing these agile principles to architecture isn't taking away from the foundational role that architecture has. We are simply reimagining it. Now, one of the things that we've often heard when we talk about this, and particularly when you look at the heritage of microservices and the heritage of evolutionary architecture, is the only evolvable architecture is a microservices architecture. And to me, that's false. That's completely false. Different architectural styles are evolvable in different ways, and you might get the maximally evolvable architecture with a certain kind of microservices architecture, but that doesn't mean you can't evolve other architectures. About the only one you really can't easily evolve is the big ball of mud. And so one of the things that we want to think about as we are trying to introduce an evolutionary architecture thinking is, how do we remediate our big balls of mud? And I'll talk about that towards the end. As I said, microservices in many ways represents kind of the pinnacle of evolutionary architecture because they are separately deployable, because they are independent processes. You can much more readily change something in one microservice, and assuming you've structured your boundaries correctly, you will be minimizing the blast radius of any change that you are making. But in many ways outside of deployment, a structured monolith is really just as evolvable. If you do a good job of keeping your component boundaries solid and structuring your monolith properly, you can get many, not all, but many of the benefits of an evolutionary architecture. You can't do independent deployments of different parts of your monolith, obviously. But I want to reinforce this notion that you don't need to go all the way to a microservices architecture to get many of the benefits that we talk about with respect to evolutionary architecture. Layered monoliths are a little harder because the layered monoliths tend to reflect technology and not the business concepts and the business processes. And one of the things that we try to look at in building an evolutionary architecture is getting the pieces such that we can reconfigure them to support new ideas of services to deliver to our customers, or new ideas of how we might re-engineer our internal business processes to be more efficient or to deliver better services. And layered monoliths are not as conducive to this as a structured monolith is. The micro-kernel architecture, again, you do have the ability to do lots of different evolution around the edges. But the micro-kernel architecture is a bit more like that adaptable architecture, is in that you've had to sort of predict in advance. These are the kinds of changes I'm going to want to make. And so there are aspects of the micro-kernel architecture that are very, very evolvable, but some that are not. Because if you don't have the right kind of slot to put something in, you're back really more in the monolith category. So let's talk about some principles, some of the principles that underlie evolutionary architecture. And some of these principles deal with decision making. Some of them, the actual practice of architecting and developing, how systems communicate with each other. And then, of course, we always have to deal with the pesky people problem, because unfortunately, that doesn't go away. And although many people have said, well, can you use this to solve this problem for me? Evolutionary architecture is no more of a silver bullet than anything else. And there are some problems, be they organizational or people, that this is not going to solve either. Sorry to disappoint. So the first is, when do we make decisions? And one of the principles for evolutionary architecture is to wait as long as possible. And I then often get asked, how do you decide what the last responsible moment is? Well, there are going to be some organizational constraints around that. Maybe you've got a very long procurement process within your organization, in which case you might have to make a decision earlier. But you want to delay so that you can get as much information as possible. And part of what's going to guide you in what kind of information you want are those fitness functions. When you've gone through that initial step of saying, these are the things that matter, these are the architectural characteristics that are the biggest determiners of success for my application, that's going to tell you where you need to focus your information gathering about your architectural decisions. So choosing those fitness functions and making those hard choices of, yes, this is what's important to me. In that trading system I worked on early in my ThoughtWorks career, what really mattered was the communication infrastructure, because they never wanted to lose a message. Every message was worth billions of dollars. So we focused a lot on how are we monitoring how a trade is flowing through the system, and is it getting stuck somewhere? We spent much less time thinking about the normal performance characteristics because it wasn't important to us. architect and develop for evolvability. When we think about evolvability from the perspective of architecture, we are going to want to be focusing again on where are we drawing our boundaries. Go back to the discussion we had about the difference between the structured and the layered monolith. We want as much as possible for our boundaries to be drawn around the concepts that exist in the business. Much like in microservices, there's a strong sense of domain-driven design here as well. And of course, as architects, we need to make decisions about how closely we couple things. Not everything should be loosely coupled. Obviously, the more loose the coupling, the easier it is to change them independently, but maybe these are things that don't change independently or rarely change independently, and you might get a benefit from coupling more tightly. And from a development perspective, the thing about evolvability, the single most important quality is how easy it is to understand what the current code does, because you cannot change something that you do not understand. And so if we are going to want to evolve anything about our system, we are going to have to be able to understand it. And so code quality and all of those metrics around understandability are crucial in evolutionary architecture. Now, in terms of how we communicate, we want to be as forgiving as possible on what we read and as conservative as possible in what we write. Because anything we expose, we don't then know who it is that's going to rely on it. And so there may be coupling that we don't know about. And we want to be forgiving about what we read, asterisk, make sure you don't open up a security hole. We want to be forgiving about what we read so that we only have to change when it's absolutely necessary. If you're getting an address and all you care about is the postal code because you're doing some kind of geolocation on that basis, don't validate the rest of the address. You don't want your integration, your use of that service to break if they decide to go from 2 address lines to 1. You shouldn't have to change in that circumstance. But if they decide to change something about the postal code, you're going to have to change regardless. So be forgiving in what you receive and be very conservative in what you send. Now, of course, I'm from ThoughtWorks. I have to talk about testability. But over the years, one of the things that we have found is the more you think about the testability at all of the different levels within your architecture, the more likely you are going to come up with those kinds of clean boundaries. If you have a test that's test this and this and this and this, and of course there's that and that and that, you probably don't have a very clear concept of what that thing is that you're testing. And that probably means it's too big. This also steers you away from putting, say, code in stored procedures or along a communication pathway. Because if you're putting some kind of code on a connection between point A and point B, that code probably assumes it's going from A to B. So what happens if you want A to talk to C? How is that going to work? Dumb pipes, smart endpoints. That gives you the greatest flexibility to be able to reorganize things. And then finally, Conway's law. We can't get away from Conway's law. Many people have tried. In fact, we've started talking internally about the inverse Conway maneuver, where you think about what kind of architecture you want, and then you reconfigure your teams and then just start working and you get the architecture that you want. By aligning the organization to your architectural goals, you're going to reduce all of those communication barriers that so often impact our ability to deliver the kind of system that we want to deliver. Okay, not only am I talking about the dreaded A word, architecture, but I'm going to talk about the dreaded G word, governance. Because one of the things that we have recognized about architecture in this new world of agile software development, but also in this change, this level of technological change, is the way we approach architectural governance also has to change. We aren't in a position where a small group can be responsible for making all of the architectural decisions for an army of software developers. I've been in organizations where the central architecture team is maybe 15 or 20 people, and they're trying to support 10,000, 15,000 developers. You just have to do the math and say, there isn't any way that small of a group can have sufficient understanding of all of the different programs that are going on to be able to make the right architectural decisions. But that doesn't mean that there aren't architectural decisions to be made. And so one of the things that we want to talk about from a governance perspective is, let's use fitness functions as one of those mechanisms for governance. And the architects can encode within fitness functions, these are the guardrails that we want the teams to respect. And the more these fitness functions are automated, the more time the architects can work with individual teams on the tougher problems. So let's say you have a staleness criteria for security, but you also have a particular performance metric that you want to make. And so, you have these fitness functions that are trying to look at, okay, can I get my performance without violating my staleness criteria? Well, maybe the team can't. Maybe they can't get those things to work together. That's what you want the architect to be helping out with. What are the different strategies, or what kind of trade-offs might we make on maybe the performance criteria, or is there a different way of approaching the problem so that we can simultaneously get meet our staleness criteria and our performance requirement? As opposed to having to do code reviews where you're looking for things like cyclic dependencies. Netflix Simian Army is a great example of this. Nobody in the Netflix ecosystem has to worry about whether or not REST endpoints are properly configured, because one of the members of the Simian Army will toss out anything that isn't properly configured. So all of these things that you can automate means that the architects can spend more time thinking about how to solve the outliers. And an important aspect, particularly when we start to think about the level of change that we want to be able to support, technological change, is to focus on outcomes and not implementations. In the past, architectural guidelines generally came down as, you will use this messaging application, you will use this database, you will use this particular implementation. And the teams would very often be sitting there puzzled, why do I have to use this when I don't actually need this? If I had this over here, my outcomes would be better. One of the major disconnects that I see between architecture groups and development groups are that they don't understand each other's problems. Architects have a medium to long-term perspective. That's what they're supposed to have. They're less concerned about, can I get things done by the end of this iteration, and more concerned about, how does this fit into the overall asset landscape, IT estate that I have? How does this fit in? And am I addressing my needs for compliance and recoverability and all of those kinds of things? Fitness functions, these architectural fitness functions, give architecture groups a way of communicating the outcomes that the architects care about. And the more that we can focus these fitness functions on outcomes and behaviors as opposed to implementations, the more we can empower the teams to make decisions that will obviously achieve that outcome. The fitness function will fail if they don't, but maybe they can use a different implementation that will give them more greater productivity. Or maybe it's a new technology that hasn't been used yet within the enterprise, but is actually quite well suited for that particular application. And yes, we need to make sure we worry about technology proliferation. But what's important is to focus on that outcome and to change the mindset of governance to worrying about what the system does and is it doing what it's supposed to do, as opposed to how does the system do what it does. And making that mindset shift from a governance perspective, automating as much as the governance as possible, focusing the governance and the oversight activities on the places where you really need the brain power. That is the goal, and that is achievable in this kind of governance process. So, sounds wonderfully aspirational. And if I was in a startup, I can see how I would do that. I'm sure many of you are thinking that. But what do I do when I'm in an enterprise where I have multiple generations of legacy working under different technological regimes? How do I do this? Well, you still start in the same place. You want to define that architectural fitness function, that overall enterprise, and the individual fitness functions that make it up. What are the things that matter for that application? Is it performance? Is it code quality, potentially? Does it have to do with maybe, issues around data? There's a broad range of things, but pick the things. What are those that matter for this system? And get those fitness functions defined and, if possible, automated. But you don't want to start breaking the build, because chances are, if you're like most organizations, you're going to be far from what you consider your ideal state. You're going to have some messy places around that estate somewhere. So you want to select that dimension that you're most worried about. Now, I'm specifically not saying where you think the change is going to come from. You can't predict that. Which one are you most worried about? One of my favorite techniques for figuring this out is to go talk to the support teams and find out when they start canceling vacations, when they hear that a particular part of the system is going to change, or maybe scheduling vacations so they don't have to be here when that part of the system changes, because it always breaks. You can look at error logs, at your bug backlog to see where bugs tend to creep in the most. That might be something. Maybe you do know about an acquisition or a merger that is being discussed, and that might mean there's an integration issue that you need to tackle. But select something based on what you know, not based on what you think. And then start working on that dimension. Do what it takes. Focus your attention on those things that you're most worried about and that matter the most. Now, I used to be a university professor. I would love for there to never be any bad code anywhere in the world, no technical debt whatsoever, anywhere. Everything's up to date. All is wonderful. I happen to live in the real world, unfortunately, and I realize that that's not the case. And so there may be things that you find that are really bad and really violate your fitness function. But right now, it's not hurting you. And if it's not hurting you, and you've got other things that are actively hurting you, pay attention over there. Ignore that smelly thing. And maybe by the time you actually have to do something about it, you have an alternative and you can just throw it away. So many times I see people wanting to focus on where the messiest problem is, when it may not be the messiest problem that's causing you the most pain. So focus on the pain, not the level of problem. And then monitor trends. This is so critical. Even if you haven't started, say, breaking the build on a code quality metric, you still want to monitor it. You want to see what's happening to it, because what you don't want is, while you're changing other things, for other things to get worse. If something happens that makes a fitness function get even worse than it was before, you want to take a look at that and decide, is that something I want to fix now? Even though it's not up to the level I want, do I really want it to get that much worse? Maybe you do. Maybe it's not a pain point, but you at least want to know what's happening. In many ways, trends are far more important than absolute numbers. If you have, for example, a code quality metric that's bopping along and then suddenly takes a dive, well, what happened? Or if you have performance numbers that are roughly okay and then they take a dive, what happened? Did I introduce inherently more complex functionality that I have to rethink my approach to performance? Or did I make a mistake? So monitor your trends. And you need to evolve your fitness functions. The technology landscape does not stay static. Your organization does not stay static. The expectations of your customers do not stay static. So you need to be evolving your fitness functions. Not every day. Some of the fitness functions probably aren't going to change much, but you at least want to be reevaluating these fitness functions on, say, a quarterly basis or a half-year basis to make sure that they still make sense in your context. And in particular, when you're going through this process of remediating something, you want to be also evaluating, okay, what is now the next most important thing? Think back to, our notions of iteration planning. What is the next most important thing that I want to fix in my system? And focus your attention there. But be constantly evaluating, are these the things that matter to me? One of the things that we're doing in this context is we're actually redefining what the target architecture is. In the past, the target architecture was a diagram, a big diagram up on the wall that had lots of boxes and lines, and that was the target architecture. And maybe it was a series of diagrams. A target architecture, from the perspective of evolutionary architecture, is actually the logical composition of all of the individual fitness functions that operate on a static level with code, or maybe they're monitoring production or anything in between. But it's that composition of the fitness functions that is your target architecture. And that target architecture is being specified, again, not as, here's the way that we implement all of these different boxes, but here are the behaviors that we want our system to exhibit. By focusing on outcomes, we allow then the implementations of those outcomes to evolve as the technology landscape changes. If we're too focused on implementations, we are constrained in how we can evolve. And so we want to move away from that. The technology landscape is not going to stop changing. The expectations of our users are not going to stop changing. people now, when they come up and whisper to me on the stage, they're not calling me professionally irresponsible anymore. They're saying to me, I know that I've got to do this, but I have no idea how. There are lots of things about how to build an evolutionary architecture that we're still learning, but the need for it is here to stay and is, in fact, only getting more acute. Thank you.
Thank you very much, Rebecca. I found myself enthusiastically nodding all the time, so I'm sure the audience enjoyed it as well, and I'd like to see whether we have any interesting questions. So let's start with this first one. That's actually, I think, an interesting one. How much of a vote do we as architects or software architects actually get in all those matters concerning organizational aspects?
That of course varies radically by organization, but one of the things that I found is architects who can communicate within the organization about the business value of what they are trying to achieve or the outcomes that they are trying to achieve actually have a lot of influence. Mm-hmm. Some of the best architects that I've known, they just understand how it is as an organization we derive value from the enterprise estate. And by leveraging that and then saying, okay, if we move these things around, if this is what you want to achieve, you are more likely to achieve that objective. Mm-hmm. Now, one of the problems is, and one of the organizational constraints very often is, the appropriate organizational structure to respect Conway's law is not necessarily the most cost efficient. Mm-hmm. And so that's why we have to be able to speak in terms of what is the value that you are going to unlock by making this change, because it is going to come at a little bit of a cost. Mm-hmm. But our architects, when they can have those kinds of conversations, in my experience, have a great deal of influence.
Mm-hmm. So would it maybe be fair to say that if you want to achieve your technical goals, better learn how to talk about the non-technical ones?
Absolutely. Okay. I had somebody come up to me once and say, I have not been able to get them to convince them to allow me to run the database recovery test. Mm-hmm. And I said, well, what do you what's your argument? Practice on me. And they were talking about indexes and, I said, no, this is a retailer. Ask them, do you want to know how long it's going to take to get back up if you're a US retailer on Black Friday? Mm-hmm. Would you like to know whether that's going to be 2 minutes or 2 hours? He went back, gave exactly that argument, and won. No question. Oh, you mean we might be down for 2 hours on Black Friday? Ah!
Makes sense. Okay, thank you. Next question. How many of those concepts are actually applicable when you deal with a lot of commercial off-the-shelf software?
You're probably more dealing with it at the level of the integration points. Mm-hmm. for the packages. But one of the things that we definitely encourage as well, when you're looking at packages, think about some of the ilities. Think about also how appropriate that package is to be part of a continuous delivery environment. So many packages still want you to do the doodleware to deploy it. That isn't what you want people doing at 3 o'clock in the morning on a Sunday. And so you want to bring as much of that thinking in terms of what is important to me in your evaluation criteria, and then also look at to what extent can I protect myself from changes in that package, because you don't have any control on the changes they're going to make. So you need to protect yourself if you're interfacing it. But most of it is really down to how well does it fit in with your architectural objectives.
Okay, next one then. Can you give us an example of a fitness function for an architecture that you have created?
Oh, there are lots of them. One of my favorites, this isn't one I created, but I think it really demonstrates kind of the creative thinking. We had a client, and their legal department was paranoid about license changes for open source software. And he said, he first asked, well, of course, all the open source contributors will notify us when they change their license, right? And yes, that was the reaction. And so people started talking about, okay, so should we be parsing these? And it's like, no. Very simple. They hashed every one of the license files for all of the open source projects and put in a very simple fitness function that compared the hashes at a build to the hashes that they had. And if any of the hashes didn't match, it sent an email to the lawyer. So perfectly simple. It would detect that a file had changed, and then let the lawyer do his job. Let the lawyer decide whether or not the change is something that we would have to impact. And I just thought that was such a clever solution. Rather than trying to do something really complicated, it's like, well, actually, all we really need to know is, has it changed or not? So let's do something simple. But in terms of the breadth of things that fitness functions can do, look at the simian army. The simian army is basically, a whole series of different kinds of fitness functions, encapsulating many different kinds of architectural characteristics.
Okay, thank you. Next one. One example of a fitness function is test coverage. Such KPIs or key performance indicators push teams to write unit tests in places where they aren't necessary. How do you overcome that situation?
That is the problem with any metric, is they can be gamed. So one defense is to make sure that you're not setting it to an extreme. Some people will say, we must have 100% test coverage. That's bound to get things gamed. And there is still also the role for sort of collective code responsibility. And so, if you start to see those unit tests that really don't do anything, well, you have an obligation to remove those. And if that means that you're dropping below the threshold, and yet it's a sensible set of unit tests that you have, that should be triggering a conversation with whoever is setting the fitness function that says, actually, in this particular instance, this doesn't make sense.
Okay.
I would also, though, put that in the category of the people problem, that some people are just going to game whatever you come up with, and you've got to figure out a way to manage them.
We've all seen that, I guess.
Yes.
Okay. Next one. As a fairly junior architect, you can tell this is not my question. As a fairly junior architect, should I jump on this idea or ignore it? Because it puts some of the classical architecture ideas on its head. And I feel I'm about to spin.
I wouldn't ignore it. That doesn't mean you necessarily want to fully embrace it right away, because having some architectural experience, and this is what makes it hard to be an architect, actually, is so often you're in a place, and so you've got a particular problem set and a particular technology stack, and so you don't get a whole lot of chance to learn and experiment. So I would try to develop your architectural experience and your architectural taste, but keep these things in mind, because the technology landscape is going to continue to change on you, whether you want it to or not. One of the things that we've done as a companion to the book, by the way, if you go to evolutionaryarchitecture.com, there are some architectural katas and fitness function katas to give you a chance to practice. Okay, here's an architectural situation, and we do these in our workshops. What are the key architectural characteristics? What might some fitness functions look like that would allow you to solve that problem? And so we're extending this notion of architectural katas to take into account the fitness function as well.
Okay. Next and probably last one. Do you have any strategies to introduce these ideas in an environment that's very resistive to change?
I usually try to start from the premise, show, don't say. And there's some of these that you can start to introduce relatively risk-free and without a whole lot of organizational air cover. Okay, let's start talking about how we might make this system less coupled to give us some more flexibility. You can also point out, well, if we did this, then this other thing that you asked for is going to take a lot less time, or be, or be much more effective. And so looking for opportunities to try to show that to show that there's a different way, and to demonstrate that you can start to improve. Sometimes, even simple things like, okay, I'm going to institute a fitness function around, say, code quality. Not going to break the build, but it's just going to do a dashboard, so that I can start having conversations with people about, okay, well, maybe there's something that we can do here together to make this better. And then after a period of time, you can show results. You can show how things have gotten better. But generally, if they're resistant to change, you have to find some way that you can actually demonstrate to them there is value here. Talking is not going to get you anywhere.
Okay. Well, Rebecca, thank you very, very much for all those insights. I enjoyed it very, very much. I'm sure the audience did as well. Hope to see you at one of the next conferences. Thanks again, and enjoy your day.
Thank you, Stefan. I appreciate it.